Chapter 1, Number Systems. 1.1, Real Numbers. The real number system evolved over time by expanding the notion of what we mean by the word number. At first, number meant something you could count, like how many cows a farmer owns. These are called the natural numbers, or sometimes the counting numbers. Natural numbers. The symbol used is capital N. We write in curly bracket, start with 1, 2, 3, 4, 5, and so on. The used 3 dot at the end of the list is a common mathematical notation to indicate that the list keeps going forever. At some point, the idea of 0 came to be considered as a number. If the farmer does not have any cow, then the number of cow that the farmer owns is 0. We call the set of natural numbers plus the numbers 0 the whole numbers. Whole numbers, the symbol used is capital W. Is natural numbers together with 0. For example, 0, 1, 2, 3 and so on. Integers, the symbol used is capital Z. Is whole numbers plus negatives numbers. For example, -4, -3, -2, -1, 0, 1, 2, 3 and so on. If we add fractions to the set of integers, we get the set of rational numbers. Prime numbers are natural numbers greater than 1 that can be divided by itself and 1 only. For example, 2, 3, 5, 7, 11 and other numbers. All number of the form P over Q, where P, Q, are element of integers, but Q not equal 0, are called rational numbers. From the diagram given, the bottom of the fraction is called the denominator. The top of the fraction is called the numerator. Rational numbers include what we usually call fractions. Notice that the word rational contains the word ratio, which should remind you of fractions. Restriction. The denominator cannot be 0. But the numerator can. All integers can also be thought of as rational numbers, with a denominator of 1. When a rational number is written in the decimal form, the digit s after the decimal point repeats itself or terminates. Example 1. From the diagram shown, we can say 3 divided by 1 equals 3.00 and so on. After decimal we can see repeat number is 0. So we can write another form, 3.0 bar. The bar represent as repeated number. Other example, 28 divided by 9 equals 3.11 and so on. So we can write another form, 3.1 bar. Last example, 3.123456781234567 and so on. So we can write 3.1234567 bar. Example 2. From the diagram shown, given the example for terminating decimal, 1 over 2 is equals 0.5. 1 over 4 is equals 0.25. We can see there is no repeat number after decimal. This means that all the previous sets of numbers, natural numbers, whole numbers, and integers, are subsets of the rational numbers.